This is the Organization and Architecture term project of the team of Sam Kuhl,
Kenny Grovenberg,
Michael Bailey,
and Shivali Gupta. For our project, we are calculating the result and rounding error of a floating point number taken to an integer power. Assuming a 64-bit precision, we are utilizing a fused multiply and add operation, allowing the computation of a times b plus or minus b with one final rounding only.
both of the following algorithms use round to nearest rounding mode. Algorithm 2, fast2mult, is C is set equal to the floating point number nearest to a times b. D is set equal to the difference between the product of a, b, and the rounded value of c. This entire thing was implemented using the available FMA instruction through the C library math.h.
The second algorithm, Lin power, has x equal to the original floating point number, n is equal to the power to which the floating point number will be taken, and h is then first given the value of x. This will eventually hold the rounded floating point result at the termination of the Lin power function. L is then initialized to 0, and this will eventually accumulate the rounding error from sequential fast2mult calculations. The function iterates through the for loop until the I, the counter, is equal to n, which is the power. In our implementation, v will receive the FMA calculation from the fast2mult function, and v actually replaces the variable d seen in the algorithm 4 in our implementation.
The program demonstrates these algorithms by the use of the linear power method, passing in parameters by reference to simulate passing two values back, and from the linear power and the fast2multiply algorithms. And to demonstrate, small numbers such as 12.4 times n, or raised to the n third, gives us power and rounding error. Larger numbers raised to even larger powers still gives us fairly big rounding errors. Negative numbers as well still produce rounding error. As such, while some of the rounding error may be lost to significant digits, it's still very important to keep in mind when making large-scale calculations.
This concludes our term project presentation.